This video is about correlation and regression, and the data that we've got here is reaction time based on the blood alcohol level. There's a pretty established link here, and it's that alcohol slows down your body, and as a result of that, reaction time is one of those things that is lengthened. So there's a fairly plausible link here. Now the first thing that we need to do here is to actually obtain a scatterplot, and I'm going to do that fairly basically. So I'm going to just highlight these columns and go to insert, because I want to insert a scatterplot, and I want one that just shows individual points, and I just need to put that in your view. So the scatterplot that we've got looks something like that. Now there's lots of things we can do with that scatterplot, and it's not really that. Well, I'll just quickly show you. We can do this to alter what it looks like. I like maybe that appearance perhaps. No, I'm not real happy with that appearance. But you can alter the appearance by doing that. And if you were handing this work in or something, you could do that and change the axis title or whatever. So okay, we'd write on here which thing was on which axis and that sort of thing. It's blood alcohol level on the x-axis and reaction time on the y. Now if we look at that graph though, you'll notice that the points form a fairly good line. So from the look of that graph, we could say that there's quite strong correlation to do with that. So, but let's go through the process of working out what the correlation is. So what I'm going to need to put that off to the side. I'll just leave it there, and I'll go here, and in this, I'll do it in this cell. I'll write the word correlation. And to be precise, what we're finding is the correlation coefficient. Okay, and we'll put the correlation coefficient in this cell here, B10. Now, to put in a correlation coefficient, it's a formula. So you need to click on the Formula tab, More Functions, Statistical, come down the list until you find correl, which is short for correlation. And you need to just put in, it calls them arrays here. It doesn't say X's and Y's, so the two arrays. So we click on this little sort of icon-y thing that represents a spreadsheet, and we go to the spreadsheet, and I think I'll put in this column first, and then click back on that icon. The second column, I click on the icon, go and highlight the second column, click back on it. And they match up. Notice that it's got like B2A2, B9A9, so they're perfect matches. Click OK. And notice that the correlation coefficient is 0.96, which is really very good. It's indicating strong correlation. And because it's indicating strong correlation, we should go ahead and we should find things about the regression line. So the first thing we'll want here is the slope, and equals, and underneath we'll go with the y-intercept. Okay. Equals. So in this cell, we need to put another formula that will give the slope. So that's more functions, statistical, come down to slope, Okay, this time it doesn't just want the two columns of numbers, it wants the x's and y's defined properly. So, in other words, the dependent and independent. So, we'll click on that little icon. Because I only use a small video screen. Yeah. This was the y column, so these are the y values. Okay, and they're entered. Then the known x's, press on the little icon, go to your spreadsheet, highlight those, press back on that icon, just have a look, do they line up? B2, A2, B9, A9, they line up, click OK. So the slope of that line is 0.63 approximately, and the y-intercept, so more functions, statistical and intercept, this one goes under. And same process, we need to put in our known y's, which is this column, and then our known x's, which is this column, and click OK. Alright, so now I might, okay, I've got very little space here left, so in this cell I'll just write the equation. So the equation would be, let's say, reaction time, that's our dependent variable, is 0.96 times by the alcohol level, blood alcohol level. In fact, we could do that. That's a fairly widely accepted sort of acronym. So we could go blood alcohol level plus the y-intercept is 0.63, and that's our equation based on I'm sorry, I've really got that wrong, haven't I? I'm looking all in the wrong places. The y-intercept was 0.24, and 0.96 was the correlation as 0.63. My apologies for that. So that's the equation that we think applies. Okay, so if there's a 0 blood alcohol level, 0 times something is 0, so we get 0.24, which is pretty much what's in the table up here. And if we substitute about 0.1 in, so 0.1 times by 0.63 is 0.063, which gives us just over 3. Okay, yeah, that's pretty close. Pretty close. We don't know how that data falls there, but anyway, that's our regression equation for the data that we've been given.